Hello everybody and welcome to another Mystery Box Function Challenge. In the purple mystery box there is some math and your challenge is to figure out what it is. You can use the link in the description to try this out on your own, and when you've got an idea, come on back and see if we get the same thing. Alright, let's start with a 0. Okay, 0 gives us 0. How about 1? 1 gives us, well, that is it's close to 1/2, but it looks like a non-repeating decimal. Okay, how about a 2? Another non-repeating decimal. How about a 3? Oh, and that's way up high off the graph. Okay. I'm thinking maybe a trig function. Have you got some thoughts about this? Although it's a little odd, not what I expected around pi. Let's put in an approximation for pi. Yeah, very, very large value. Okay, so that is shooting up off the graph. So what I'm thinking of is one of the trig functions that have these asymptotes, and that would be like the tangent or maybe the cotangent or the secant or the cosecant. Let me just look in the negatives here. Mhm. Yeah, so to me, this is kind of looking like the tangent. It has that sort of center here right at 0, and the tangent of 0 is 0. And then it goes up on the right and down on the left and shoots off to infinity. This just looks a little bit fatter than I would expect, a little wider and stretched out than I would expect for the tangent. So what the tangent does, let's take a look at this really quickly. So the tangent is the sine over the cosine, and those are the y and the x coordinates of where the angle intersects that unit circle. So here at the point 1, 0, the tangent is 0. It's 0 over 1, the y over x. Here at pi, it's also 0 because it's 0 over -1, because our points here are -1, our coordinates are -1, 0. So you would expect tangent to go through its whole cycle basically between 0 and pi. What we're seeing is that pi, our approximation for pi, is really big. So it's going to be shooting up at infinity. That's what we'd expect here at pi over 2. And you can see why. This is the point 0, comma 1. So we would have 1 over 0. And that, of course, is going to be undefined. But as you approach closer and closer to 1 over 0, you're going to approach closer and closer to infinity. So here, the tangent of pi over 2 is infinity. And we're getting that not at pi over 2. So if we put in an approximation for pi over 2, so 1.6, we're just getting a little over 1. We're getting that at pi. So it's as if it's taking twice as long for the tangent function to get there. So I could expect it to be back to 0 at 2 pi if that's the case instead of pi. So an approximation for 2 pi would be 6.28. Let's see what we get there. Yeah, and we're basically at 0. So I think we've got this actually. We just have to know how to write that. How do you stretch out the period of that function? In this case, what you're going to do is you're going to have a fractional multiplier inside the parentheses. So instead of the tangent of x, this is going to be the tangent of, well, and I think we're doubling the length of period, so it's going to be multiplied by 1/2. So 1/2 times x, or x over 2, however you want to write that. So I think that is going to give us the correct answer. If you think about it, if you put in pi for x, it takes it over 2 first, so you're going to get the tangent of pi over 2 at pi, and that's infinity. That's what we're getting there. At 2 pi, you're going to take the tangent of pi because it cuts it in half first, and that's what we're getting there, basically 0. So I think we've got it. I'm going to go ahead and check. Yeah, the tangent of x over 2, and we can graph that as well. Yeah, and you get those nice curves of the tangent, just twice as wide as we're used to seeing. Well, how did that go for you? Were you thinking trig? Let me know. Thanks, everybody.